JEE Advanced 2021, Paper 1, Question 19. Physics, Thermal Radiation and Cooling. Let us visualize the setup. A small object is placed at the center of a large evacuated hollow spherical container. The container is maintained at 0 Kelvin, absolute zero. At time t equals 0, the object is at 200 Kelvin. Since both are ideal black bodies, the object radiates heat outward in all directions. With the surroundings at 0 Kelvin, there is no incoming radiation, only emission from the hot object. The object cools down purely by thermal radiation. The question states, a small object is placed at the center of a large evacuated hollow spherical container maintained at 0 Kelvin. Both are ideal black bodies. At time t equals 0, the object temperature is 200 Kelvin. It cools to 100 Kelvin at t equals T1, and to 50 Kelvin at t equals T2. The heat capacity of the object does not depend on temperature. Find the ratio T2 over T1. This is an integer type answer. The key concept is the Stefan-Boltzmann law. A black body radiates power P equals sigma AT to the fourth power, where sigma is the Stefan-Boltzmann constant, A is the surface area, and T is the absolute temperature. Since the surroundings are at 0 Kelvin, there is no absorbed radiation. The net power loss is simply sigma AT to the fourth. The heat loss equation becomes mc dt over dt equals negative sigma AT to the fourth. This is crucial. The rate of cooling depends on T to the fourth power. At 200 Kelvin the radiation is extremely intense, but at 50 Kelvin it is negligibly small. Step 1. Set up the differential equation. The heat loss equation is mc dt over dt equals negative sigma AT to the fourth. We separate variables, bringing T to the fourth to the left and dt to the right. dt over T to the fourth equals negative sigma A over mc times dt. Let us define K equals sigma A over mc, a positive constant. Then the equation simplifies to dt over T to the fourth equals negative K dt. Step 2. Integrate both sides. We integrate T to the minus 4 dt on the left, from the initial temperature T0 to T, and negative K dt on the right, from 0 to T. The integral of T to the minus 4 is T to the minus 3 divided by minus 3. After evaluating the limits and rearranging, we get Kt equals 1 over 3T cubed minus 1 over 3T0 cubed. Here T0 is 200 Kelvin. Notice that 1 over T cubed increases linearly with time. This is the key relationship. Step 3. Calculate Kt1 and Kt2. For T1, the temperature drops from 200 to 100 Kelvin. Substituting, Kt1 equals 1 over 3 times 100 cubed minus 1 over 3 times 200 cubed. Computing, 100 cubed is 10 to the 6, and 200 cubed is 8 times 10 to the 6. Taking the common denominator, we get 8 minus 1, over 3 times 8 times 10 to the 6, which equals 7 over 24 times 10 to the 6. For T2, the temperature drops to 50 Kelvin. 50 cubed is 1,25,000. Similarly, Kt2 equals 64 minus 1, over 3 times 8 times 10 to the 6, which equals 63 over 24 times 10 to the 6. Step 4. Compute the ratio T2 over T1. The ratio equals Kt2 divided by Kt1. The K cancels, and the denominator 24 times 10 to the 6 also cancels. So we get 63 divided by 7. Since 63 equals 9 times 7, the ratio simplifies beautifully to 9. T2 over T1 equals 9. The answer is 9. The ratio T2 over T1 equals 9. Using the integrated form of the Stefan-Boltzmann cooling equation, the time for the object to cool from 200 to 50 Kelvin is 9 times the time to cool from 200 to 100 Kelvin. This dramatic ratio arises because the T to the fourth dependence means cooling slows drastically at lower temperatures. Exam tips for JEE Advanced. Tip 1. Stefan-Boltzmann law states P equals sigma AT to the fourth for an ideal black body. Tip 2. When surroundings are at 0 Kelvin, there is no absorption, net radiated power equals sigma AT to the fourth. Tip 3. The integration of T to the minus 4 dt gives minus 1 over 3T cubed, just the standard power rule for integration. Tip 4. When heat capacity is independent of temperature, mc is a constant, which makes the differential equation separable and straightforward to solve. Remember this quick reference formula card for similar problems. If you found this helpful, like and subscribe for more JEE Advanced 2021 solutions at MAGPIEHUB.